Hi guys, so we're going to be looking at how to find the slope between 2 points. So we got some notes up here to go over. So slope is our direction and steepness of a line. You often will see slope written as a positive or negative fraction. It won't always be a fraction, but a lot of times it is going to be a fraction. It could be a whole number or a decimal or a fraction, but most commonly you'll see it as a fraction. Okay. Now when I'm finding the slope of a line, I'm looking at the direction of it and the steepness of it. When I talk about directness, I'm talking about does it have a positive or a negative slope. I know a line has a positive slope if it's going up, left to right. I know my fraction will be positive. If my line is going left to right and it goes down, I know my fraction will be negative and that line has a negative slope. Okay, so that's my direction. I either have a positive slope coming up or a negative slope coming down. There are a couple exceptions for if a line is completely vertical or horizontal, but primarily going up, positive, going down, negative. Then I have my steepness of my line. Steepness of my line is often found by doing your rise over run. You can think of it as your vertical change over your horizontal change. So when I say vertical, I mean up and down, and when I say horizontal, I mean side to side. We can shorten this whole notation of vertical change and horizontal change by saying with this symbol here, this triangle. This triangle is the Greek letter delta, and it means change. It's used a lot in math and science classes. So by saying change in y and my change in x, because just like on our graphs, our y-axis goes up and down, and our x-axis goes side to side or horizontally. Okay, so I'm looking at my change in y over my change in x. Now, we're going to do some problems together. Okay, so let's say I want to find the slope between these 2 points. Okay, so if I want to find the slope between them, we have a couple different methods that we can do. Okay, I can graph them, or I can do it algebraically, and we're going to look at both of those methods here. So if I'm going to graph it, I'm just going to go through and I'm going to plot these 2 points and connect them on my graph. So when I'm plotting points, just remember that first value is always my x value, and my second one is always y. And again, same thing here, my first value is x, and my second value is y. So when I plot this point, 10, 7, I'm going to go to 10 along my x-axis, and I'm going to see where that meets up on my y-axis at 7, and I've plotted my point 10, 7. Okay, I'm going to zoom in a little bit for you guys. Okay, and then I'm going to plot my next point, negative 3, 2. So I'm going to go along my x-axis to negative 3. I'm going to see where that meets my y value at 2. And so now I've plotted both of those points, and I'm just going to connect them to make my line. So now if I want to find the slope between those 2 points, I like to use my slope triangle, and just from a point, I'm just going to go perfectly horizontal and perfectly vertical. And where those meet, I'll get a 90-degree angle following the grid lines on my graph. Okay, and this change here horizontally, this is my change in x. It's my horizontal change, and this vertical change, this is my change in y. So all I need to do is see how far apart those are. So I see this is 1, 2, 3, 4, 5. So I have a vertical change of 5. And then I do the same thing horizontally. I see I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have a horizontal change of 13. And then I'm going to look at the direction of my line. I see my line is going up, so I can tell that this has a positive slope. So the final slope of my line puts all of these together. The fact that I have a positive slope and my change in y over change in x. This leaves my final slope of my line equal to a positive 5 over 13, because we know slope is our change in y over our change in x. Okay? Now I can also solve this algebraically. I don't need to draw a graph to find slope, but oftentimes it's visually helpful. If I want to just go straight from my 2 points, I have the point 10, 7, and I have my point negative 3, 2. And as we talked about, it is our change in y values over our change in x values. Well, here are my y values. So when I talk about the change in y values, I literally mean how do I change to get from a 7 to a 2? Well, to get from a 7 to a 2, I went down 5. And then here to get from a 10 to a 3, because these are my x values. So when I talk about my change in x, I'm talking about how do my x values change from one to the next. So if I'm going from 10 to a negative 3, I will have gone down 13. And you'll notice these are the same values, but you notice the sign's a little different. We're going to talk about that. So when I write my slope, slope is my change in y over my change in x. So in this case, my y value changed by going down 5, and my x value changed by going down 13. Well, here I just have a negative number divided by a negative number. And you guys know that a negative divided by a negative is a positive. So overall, I have a positive fraction of 5 over 13. So we just have to look at those values a little bit. Okay, and that's how you find slope. We're going to look at a couple more examples now. Okay, so I'm going to turn the page, and we're going to do these examples. Okay, so I'm going to, again, find my slope graphically, and I'll also find it algebraically. So to find it graphically, I'm going to start by plotting my points, negative 6, 7, and I'm going to plot the point 2, negative 3, and then I'm going to connect those. Okay, I'm going to draw my slope triangle. So from one of my points, I'm just going to go straight down. And then once I get to this other one, I'm going to go straight over, and I'm going to make sure those meet at a 90-degree angle. And now I'm just going to find that change in y is that vertical change, just like my y-axis is vertical. And my change in x is my horizontal change, just like my x-axis is going left to right. So if I count these, I see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I see I have a change in 10. And then here, if I come across, it's 1, 2, 3, 4, 5, 6, 7, 8. I see I have a change of 8. And then I look at my line. I see my line is going down. So I know I have a negative slope. And if you notice, when I write the word slope on the line, it actually angles itself down, and that helps me know this is a negative slope. I'm going to just write that word in there, negative. Okay, this line has a negative slope. Okay, so my final slope of this line I know is going to be negative because my line is going down. And then I have my change in y of 10 over 8. And out of good habits, we should reduce our fractions. So I know 10 and 8 can both be divided by 2. So I'm going to go ahead and divide both of those by 2 and reduce my fraction. And I'm going to have a negative 5 over 4 as my final slope here once it's all reduced. Now, again, algebraically, I'm going to take my points. And if I know slope is my change in y over my change in x, then I can look at my points and I can see how are they changing. So if I look at my y values, I see I'm changing from 7 to negative 3. So to get from 7 all the way to negative 3, I will have gone down 7, and go down 3 more, I will have gone down 10. Okay, so I know my change in y is negative 10. And then I look at my x values. I'm going from negative 6 to 2. So I'm at negative 6. I need to get all the way to positive 2. I'll have to go up 6 and then go up 2 more, I'll have gone up 8. So I know that my slope is negative 10 over 8, and then I'd look to reduce this as well, and I'd have my negative 5 over 4. Okay, we're going to do one more together. Okay, so I have these 2 points again. I can solve it graphically or algebraically. I'm showing 2 different methods. So I'm going to start by plotting my point, negative 5, 0. So I go to negative 5 on my x, and I don't go up or down at all because my y value is 0. And now I'm going to plot my point 3, negative 9. So 3 to my x-axis, and then all the way down to negative 9. And I'm going to connect those and have my line. Can already see, looking at the angle of this line, I'm going to have a negative slope because my line is angled down. I'm going to go ahead and label that down, that I have a negative slope. And then if I draw my slope triangle, I'm just going to go straight down and straight over. And now I'm going to find that change in y over change in x. So my change in y value is that vertical change. And I see I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So my change in y is 9. And then if I look at my change in x, it's that horizontal change. 1, 2, 3, 4, 5, 6, 7, 8. I see I have a change of 8. So when I write my final slope, my line is going down, so I know my slope needs to be negative. And then I have my change in y over my change in x. And my final slope is negative 9 over 8 because I cannot reduce it. We also do not want to change our slope into a mixed number because it's just going to make our lives a little harder later. So it's perfectly fine to leave it as an improper fraction like this as long as it's reduced as much as possible. Now I'm going to look at my 2 points, and I'm going to show you another method. I'm going to show that algebraic method. So I look at my 2 points, and I know that my slope is found by doing my change in y over my change in x. So if I look at these values, I look at my y values, and I see I went from 0 to negative 9. I went down 9. That's my change in y. And then here I went from negative 5, my x value of negative 5, to the x value of 3. And I see that from negative 5 to 3, I will have increased by 8. So I will have gone up 8 there. That's my change in x. And again, there's nothing to reduce here. So there is my final slope of a negative 9 over 8. So there you have it. 2 methods to find slope. Based off of the definition of slope of our change in y values over our change in x values. So I hope you guys found this helpful, and I'll see you guys in our virtual class soon. Bye.